Now, Ron, I understand that you have a great relationship with NASCAR. Tell us a little bit about how that works and the engineering behind it.
Well, it certainly is an engineering endeavor. We work closely with the teams, with the OEMs who actually make the castings, to NASCAR as a sanctioning body. It's a great relationship we have. I think it makes us a better gasket company. It makes them hopefully a better race engine. We also work with NHRA teams, sprint cars, you name it, monster trucks, offshore boats, you name it, we're involved. If it makes horsepower, we're in. So it's been a great relationship, and we look forward to continuing it for many years to come.
Well, what I'm looking at here is a gasket that I know is going to seal, and I'm not going to over torque it, and everything I need is in the kit with good instructions. But you know, really, everybody talks about that. And I really need to know a little bit more about the engineering behind this. I think this is really a tool, because it's going to make the job that you do a whole lot better because of, I would say, the engineering behind it.
Right, and also in understanding that, you know, the OEMs are building in a very sterile environment. As I mentioned before, things are flat, surface finishes are good. In the aftermarket, we know none of those things are generally the case. That surface finishes are a problem, that flatness is a problem. You know, if you mill the heads and you go ahead and reinstall them on the engine, you know, you shouldn't change geometry of how that intake gasket and manifold sit on the application. So those are the kind of things you have to anticipate, warn the customer about, and put some design features in that would actually prevent some of those things from happening. So that's definitely a key.
One of the things that intrigues me about engineering, a lot of times I think about mechanical engineering. Here, clearly, we're talking about chemical engineering, chemistry. Right. Tell us a little bit more about your chemical type of engineering capabilities.
Yeah, we do have, I mean, within the Federal Mogul facilities in North America as well as the rest of the world, we do have departments that's all they work on, is developing chemicals and products and compounds for us to go ahead and use in the aftermarket. So it's a relationship that's really important to us. It's a very expensive endeavor, but you know, I think the benefits outweigh the cost for sure. So you want to engineer in the right material compound, the right durometer, which is the relative softness or hardness of the material, its resistance to heat, for instance, like we were talking about before. So there's a lot that goes into it. They might all look like rubber gaskets, but you know, there actually is a reason we use that rubber or that rubber or that rubber. And then you can take that one step further. It's the design. You know, how do you use that rubber in an application that's going to make it work and last for the life of the engine repair.
That's great. Now, I can't tell you how many gaskets I've changed over time, and I know you guys have changed a whole lot too. They do not look anything like this when we take them out. And one of the things that I'm curious about is, along the chemistry lines, is plating. How do you know what to plate this stuff with so that it doesn't corrode? I'm really curious about how you come to those decisions, and how do you come to those decisions?
Well, I mean, again, you know, we don't look at new castings, we don't look at clean engines. We look at the worst stuff we can find in our junkyard to determine where the problems are going to lie. You can make the best part in the world, but if it's not made for that environment, it's just not going to work. In the case of this, we've got aluminized steel carrier, which replaces the plastic. Aluminized steel carrier is going to be very robust in terms of not only its lateral strength, but also in the fact that it's not going to corrode. In our marine line of engine gaskets, that's all stainless steel, because we know that marine engines go into saltwater environments, and therefore we need to have the right type of steel and the right type of application.
All right. Now, one last question now. You've got a lot of great engineering, chemical, mechanical. You've got a great product that you came up with. How do you know it's going to work?
Well, we test it. We test it a lot. As a matter of fact, we have a facility within our Skokie facility in Chicago. We also have Dyno Labs in Ann Arbor, the Ann Arbor area of Michigan, and they do a lot of testing for us. And the thing is, we've got a lot of different product lines, so if we have an engine on test, I can do a gasket test on an engine while they're also doing a spark plug test, while also doing a bearing test. So there's a lot of synergies there, and we can capitalize on on doing that test work, getting good data back, and spreading the cost out across not one product, but multiple products.
Great. Well, thank you very much. I feel really good about a product like this, and I think if I were to put it in an engine like that, it's going to do the job. I'm not going to have to worry about a comeback.